For decades, Pluto was the solar system's mysterious punctuation mark, planet number 9, a tiny frozen world beyond Neptune. It was the last stop on the planetary tour, a distant outpost that captured the imagination of astronomers and dreamers alike. Pluto's orbit, tilted and elongated, set it apart from the other planets, making it seem even more enigmatic and remote. From Earth, it was just a faint speck, even through Hubble's lens, a blurry, pixelated blob. Our most powerful telescopes could barely resolve its shape, leaving us with little more than a ghostly smudge on a black canvas. For generations, Pluto was a riddle wrapped in darkness, its secrets hidden by sheer distance. We imagined Pluto as a dead, icy relic, smaller than our moon, locked in a permanent freeze. Its surface, we thought, was a wasteland of nitrogen ice and rock, untouched by time or change. The frigid temperatures, hundreds of degrees below zero, seemed to guarantee a world frozen in silence. Scientists pictured a monotonous, cratered landscape, unchanged for billions of years. The prevailing belief was that Pluto was a fossil from the solar system's earliest days, a leftover building block that never became anything more. The sun, from Pluto, would be just another bright star, offering little warmth. Its rays, so powerful on Earth, would barely illuminate Pluto's surface, casting long, cold shadows across the ice. Any atmosphere was thought to have frozen and collapsed long ago. Scientists believed that Pluto's thin veil of gases would simply fall to the ground as frost during its long, cold winters, leaving the planet airless and still. Pluto was a placeholder in our planetary catalog, not a world with a story. It was a name on a list, a distant curiosity, rarely the focus of serious exploration or wonder. Our assumptions were shaped by distance and by what we knew of other small, rocky bodies like Mercury and the Moon. We expected Pluto to be just as lifeless, just as unchanging, and just as cold. We believed Pluto was just another cold, inert rock at the edge of the solar system. Its remoteness made it easy to overlook, and its mysteries seemed forever out of reach. But as we would soon discover, this simple story was spectacularly wrong. The reality of Pluto would turn out to be far more complex and far more fascinating than anyone had dared to imagine. The tyranny of distance had blinded us to Pluto's true nature. Our old view was about to be shattered by new eyes and new technology. Pluto was about to surprise us all, rewriting its story in ways that would astonish the world. In 2006, astronomers made a groundbreaking discovery. They found that Pluto was not alone in the far reaches of our solar system. Using powerful telescopes and years of patient observation, they identified more Pluto-like objects in the Kuiper Belt, a vast, mysterious region beyond Neptune, filled with icy bodies and cosmic debris. This region, stretching billions of miles from the sun, is like a cosmic frontier, largely unexplored and full of surprises. Suddenly, Pluto was no longer unique. It was just the first of many icy worlds discovered in this distant zone. These newfound objects challenged everything we thought we knew about the solar system's outer limits. The International Astronomical Union, faced with this new reality, gathered to debate what it truly means to be a planet. After much discussion, they redefined the criteria, and Pluto was officially reclassified as a dwarf planet. This decision sparked a global debate. News outlets around the world covered the controversy, and passionate arguments erupted among scientists and the public alike. For many, Pluto's demotion felt personal, but for astronomers, it was a necessary step toward understanding our solar system's true structure and history. Rather than being cast out, Pluto became the king of a new class of worlds, a leader among the dwarf planets. It was no longer an outcast, but a prototype for a whole new family of celestial bodies. Yet despite its new status, Pluto's true nature remained shrouded in mystery. What was this distant world really like? Was it just a frozen, lifeless ice ball, or did it hold secrets waiting to be uncovered? Scientists wondered if Pluto's surface was static and dead, or if it might be more dynamic, perhaps even geologically active beneath its icy crust. The best images we had from the Hubble Space Telescope were little more than blurry smudges, just enough to tease our curiosity, but not enough to provide real answers. To truly solve the riddle of Pluto, we needed to send a spacecraft there. Only by visiting could we hope to unlock its secrets and see this mysterious world up close. Ironically, Pluto's demotion only made it more fascinating. It became a symbol of exploration, a prototype for a new kind of world, and a key to understanding the solar system's outer edge. By studying Pluto, scientists hope to unlock the secrets of the Kuiper Belt itself, revealing the history and evolution of our solar system's most distant regions. The stage was set for a daring mission, one that would push the boundaries of human exploration and redefine what we know about the solar system's frontier. We needed a robotic explorer to transform that distant fuzzy dot into a real, tangible place, a world we could finally understand. And so, the quest for Pluto began, a journey that would change our view of the solar system forever. The answer was New Horizons, a probe launched in 2006, just before Pluto's reclassification. It was the fastest spacecraft ever, using Jupiter's gravity to slingshot toward Pluto. For nearly a decade it sailed through the void, mostly asleep, conserving power for its grand finale. The team had to aim for a tiny window in space and time, threading a cosmic needle. In July 2015, New Horizons executed its flawless flyby. For a few hours its instruments captured everything they could. The probe couldn't stop, it was moving too fast. The data began its long journey back to Earth. The first images were stunning. Pluto was no dead, cratered world. Instead, it was a place of breathtaking beauty and complexity. The blurry blob was gone, replaced by a vibrant, dynamic world. Pluto's real story was about to begin. The most striking feature revealed by New Horizons was a massive, heart-shaped region, Tombaugh Regio, etched across Pluto's surface like a cosmic signature. This iconic heart, gleaming against the darkness of space, instantly captured the imagination of scientists and the public alike. Its surface was bright, smooth, and almost entirely crater-free, a stark contrast to the battered, ancient landscapes we expected to find on such a distant world. The lack of craters told a remarkable story. This was a young surface, one that had been renewed in the recent cosmic past. Something was erasing the ancient scars left by impacts, hinting at ongoing activity beneath the icy crust. Pluto, once thought to be a frozen relic, was geologically alive. Active processes were at work, constantly reshaping and refreshing its surface in ways we had never anticipated for a world so far from the sun. The western lobe of the heart, known as Sputnik Planitia, was revealed to be a vast glacier made of frozen nitrogen, methane, and carbon monoxide, an alien landscape of exotic ices stretching for hundreds of miles. But this glacier wasn't static or lifeless. It moved and flowed, its surface broken into giant polygonal cells by the slow churning of convection, an extraordinary process for such a distant, icy world. Warm ice from deep below rises up, cools at the surface and then sinks again, creating a never-ending cycle that constantly renews the landscape. This dynamic activity is unlike anything seen elsewhere in the solar system's outer reaches. This discovery was a game-changer, active glaciers, flowing and evolving, on a tiny world billions of miles from the sun, where we once thought nothing could stir. For such activity to exist, Pluto must have an internal heat source, likely generated by the slow decay of radioactive elements deep within its rocky core. This hidden warmth powers the movement of ices and the renewal of its surface. The sun's faint distant light simply isn't enough to drive these changes. Pluto's internal energy is the true engine behind its living surface. Pluto's beating heart forced us to rewrite the rulebook for icy worlds. It showed us that even the smallest, most remote bodies can be full of surprises. We once believed that such small, distant bodies would be frozen solid, locked in silence for billions of years. But Pluto proved there are other ways to generate and retain heat, challenging our assumptions about what is possible in the deep freeze of the Kuiper Belt. Even in the coldest, most distant reaches of our solar system, worlds can be dynamic, evolving, and alive with geological activity, reminding us that the universe is always more complex and wondrous than we imagine. New Horizons revealed even more. Towering mountains of water ice as hard as granite in Pluto's cold. Some peaks rival the Rockies and they're geologically young with few craters. The answer, cryovolcanoes. Ice volcanoes erupting slushy mixtures of water, nitrogen, and ammonia. These icy eruptions build massive structures like Wright Mons, possibly still active today. Pluto's interior is complex, with layers and pockets of mobile material. This internal plumbing transports material from deep inside to the surface. Pluto's geology rivals that of Earth and Mars, but with ice instead of rock. If Pluto is this active, what about the other Kuiper Belt worlds? The outer solar system could be teeming with complex, active worlds. Pluto showed us the cold frontier is far more exciting than we imagined. As New Horizons looked back, it saw Pluto's atmosphere backlit, a stunning blue haze. The atmosphere was complex, with up to 20 layers of haze, not the thin shell scientists expected. Sunlight breaks down methane, creating hydrocarbon particles called tholins, which scatter blue light. These particles settle on the surface, coloring Pluto's landscape. Pluto's atmospheric pressure has changed dramatically over time. Evidence suggests ancient riverbeds and lake shores, liquid nitrogen, not water, may have once flowed here. Most tantalizing, Pluto may hide a vast liquid water ocean beneath its frozen shell, kept warm by internal heat and ammonia. If true, Pluto joins the club of ocean worlds that could harbor the ingredients for life. A hidden ocean on such a distant world is revolutionary. Pluto's complexity keeps surprising us. Pluto isn't alone, it has 5 moons, the largest being Charon. Charon is half Pluto's size. Together they orbit a common point, locked in a cosmic dance. New Horizons revealed Charon's violent past. Vast canyons, some deeper than the Grand Canyon, hint at a subsurface ocean that froze and cracked the crust. Charon's north pole is capped by a dark reddish patch, Mordor macula, likely made of tholins from Pluto's escaping atmosphere. Pluto is literally painting its moon. The smaller moons, Styx, Nix, Kerberos and Hydra, are oddly shaped and tumble chaotically. Their bright surfaces suggest water ice. The Pluto system is a miniature solar system, full of history and mystery. Each moon adds complexity to Pluto's story. New Horizons didn't find new moons, but it revealed a dynamic, interconnected system. Pluto and its moons are a world of their own. Pluto's revelations transformed our view of the outer solar system. It's not an anomaly but the archetype of hundreds, maybe thousands of icy worlds in the Kuiper Belt. Once thought empty, this region is now a bustling neighborhood of dwarf planets. Pluto gives us a template for what these worlds might be, geologically active, with atmospheres and maybe hidden oceans. The Kuiper Belt is the solar system's third great domain. Pluto was our first ambassador, showing us this frontier is full of surprises. The story of our solar system is richer and more complex than we ever imagined. Pluto taught us to see the edge not as an ending but a new beginning. New Horizons turned Pluto from a blurry dot into a breathtaking world, overturning decades of assumptions. Pluto is alive, with glaciers, ice volcanoes, a blue sky and maybe a hidden ocean. It changed our understanding of what makes a planet active. Even small, distant worlds can be dynamic and evolving. Pluto's legacy is one of wonder, inspiring new generations to explore. New Horizons continues deeper into the Kuiper Belt, revealing more secrets. Pluto's story is a lesson in humility. Nature's complexity always exceeds our imagination. The universe is full of wonders, and Pluto is just the beginning.